All right, we're going to start with 10.2 angles of rotation. Here we go. Go ahead and copy this down. And these are your normal XY coordinate planes. Notice, however, I did not put any tick marks on here, and I don't want you to in this section. We're not going to be putting any tick marks here. So we're going to be learning what's called standard position. And we're talking about angles. Yeah, we're kind of going back to geometry here. What we're going to start with is what's called your initial side. And that's going to be the first side of your angle that you're going to be drawing. Remember, an angle is just, it's two rays that, form an angle of however many degrees. So the initial side is one of your sides of the angle. And we're going to do an example. For this one, we're going to do 135 degrees. So to make an angle that's 135 degrees, if this is your initial side, your terminal side, the other ray of your angle, needs to open up so it's 135 degrees. Meaning that the angle is going to be somewhere right here. And so we're going to say this is about 135 degrees. Okay, so I just want to talk a little bit more about that. Imagine you had an angle of 0 degrees. Where would that be? Well, if your initial side of the angle is right here and it's 0 degrees, that means that it doesn't open up at all. So by definition, this right here, the initial side, is 0 degrees. So let's think about something. What if your angle stopped right on the y-axis? What if it stopped like right here, this side right here? How many degrees would that be? Well, that's a right angle. So if your angle was open up from here to here, that would be 90 degrees. And then if we kept going, we would end up right here. If we stopped right here, this would be 180 degrees. If you kept going, so let's say you extended your angle all the way around to hit this part of the y-axis, that's 270 degrees. And what if you made a full circle? Well, you would end up back here, but that's not going to be 0 degrees. That's 360. So actually, what we call 0 is if we go a full, what we call a revolution around, that's actually also 360 degrees, which makes sense because you've made a full circle. And we know that circles have 360 degrees. Now remember how I said this is called your initial side? Well, this has a name. This is called your terminal side. So any angles that are in standard position have an initial side, but the initial side is always here. Always. In fact, let's make a note of that. This is always your initial side, but your terminal side depends on what your angle is. If I chose 179 degrees, my terminal side would have been really close to 180. So the terminal side depends on where you're going. You can also have negative rotations, and all that means is that it means that your angle that's given is a negative number. So for example, let's go ahead and do negative 45 degrees. Well, this is still your initial side right here. In fact, if you want, we can go ahead and label this 0 degrees still. But to go negative 45 degrees, instead of going this way, negative angles start off going this way. Still from the initial side, but your terminal side is going to, end up going this way. Now, if you think about it, if this is 0 degrees, this would be negative 90 degrees down here if we're traveling clockwise here. So where would negative 45 be? Well, 45 is half of 90, and same thing with negative 45 is half of negative 90. So negative 45 degrees would be right here. Okay, so we have your positive rotations. They go counterclockwise. Your negative rotations go clockwise. Let's go ahead and do a few more of these. There's a few that I want to show you. Go ahead and copy these down. So this says sketch each angle into standard position, and that's what we were just talking about. That's what standard position is, going from your initial to your terminal. So I see the first one is 300 degrees, which is positive. I'm going to put a little plus sign. You don't have to do that, but it helps me. The positive helps me remember I'm going this way. So now, okay, I know 0, 90, these are all degrees, right? Let's actually put the degree symbol. 270, 360. So where would 300 be? Well, if I'm starting here, I wouldn't stop here because it's only 90. I need to go full 300. So it looks like I'm going to have to go past the 270. But not quite a full circle, right? 360 is a full circle. So, and we're just estimating. It doesn't need to be absolutely perfect, but I'm going to say it's probably about right here. And that's 300 degrees. And we like to label these things, by the way, so go ahead and label that. All right, let's try this one out. Let's see if you can do it. I want you to try this one out. Okay? If it helps you, though, let's start out, and this is a negative one. So we're going to go clockwise with negative angles. You don't need to make 0 negative, by the way. But go ahead and try negative 150 out. See if you can see where it lands. Okay, so if you tried it out, it should have landed probably somewhere pretty close to here. Okay, let's try 900 degrees out. 0, 90, 180, 270, 360. Now 900 is definitely bigger than 360. And you're allowed to kind of loop around. So let's think about how many full circles are within 900 degrees. How can we figure that out? Well, we can take 900 degrees and subtract 360 and see what we get. I'll have my calculator. I can do that in my head. It's 540. So that's one full revolution. That's one revolution. But I think there's another one that we can take out. So if we do 540 minus 360, we get 180. So here's what happens. We're going to go 2 full revolutions, like 2 full circles around, but then we're going to have to go an additional 180 degrees to end where we need to end. So now this is a positive. So I'm starting here. So watch what happens. This is my first revolution, and look where it ends. See how I go a little bit past the initial points. So that's one revolution. That's that first revolution. Now I need to go again. And that's my second revolution. So that took care of both revolutions, but I still have another 180 to go. So that's actually going to land me right here. So that's a 900 degree angle in standard position. Okay, let's talk about coterminal angles. Coterminal angles are angles in standard position with the same terminal side. So go ahead and draw this real quick, and you can write down the example as well. So I'm going to show you what it looks like as a graph, but I'm going to show you how to do it algebraically as well. So let's say, for example, I give you 120 degrees. Where would that be? Well, 0, 90, 180, 270, 360. 120 looks like it'd be between 90 and 180. Maybe closer to 90, though. So maybe like about right there. So what a coterminal angle is an angle in standard position with the same terminal side. Remember, this is the terminal side of your angle. If it helps, maybe I'll draw the initial side as, darkened in. This is your angle. Remember, this is your initial, this is your terminal. Well, what is an angle that can have the same terminal side as this? Well, what if we went the other way? What if, kind of like completed the circle? These two angles right here are coterminal angles because they share the same terminal side. But what is this angle? Well, first off, because we went this way, it has to be a negative. So, sorry, let's go ahead and say we're finding the coterminal angle to 120. Well, it's going to have to be a negative number. It's going to have to be bigger than 180 because I want a full negative 180. Well, how do I figure out this part right here? Well, if this is 90 degrees and we want a full 120 here, remember this is 120 degrees right here, then this must be 30. Which makes this what? This is 60. So this full angle is 180. And actually, we should say it's negative because we went this way. It's negative 180. Then we went another 60. And then negative 180 minus 60 is negative 240. So these are two coterminal angles. Now, there's actually an easier way to find this number than what I just did there. Is all you have to do is take 120 degrees and subtract a full circle from it. If you did that, you would get negative 240. And so I'm going to show you how to do that here. So example, find the measures of a positive and a negative angle that are coterminal with each given angle. So watch how easy this is. To find the positive one, you just take 40 and add a full revolution, a full circle. 40 plus 360 is 400. We could show a visual with that. Basically, you don't have to draw this part, but real quick, okay, 40 degrees is about right here, right? Then 400 degrees would be a full circle. So 400 degrees would be this, but it would land on the same terminal side as 40. Negative, you take the 40 degrees, that right there, and subtract 360. 40 minus 360 is negative 320. By the way, I don't think I talked about what this symbol is, did I? Okay, this little egg shape right here. I can't believe I didn't talk about this yet. This is the Greek letter theta. I want you to make a note of that. And we're going to be using theta a lot. It's the Greek lowercase, I believe it's lowercase. Maybe, I might be wrong actually. No, I think it is. It's the Greek lowercase letter theta. It's used a ton in trigonometry, so it's something you definitely need to get used to. Okay? Alright. Go ahead and copy this down. Reference angle. For an angle theta, again that's theta, in standard position, it's the positive acute angle formed by the terminal side of theta and the x-axis. Okay? So a couple key phrases there are the terminal side of theta and the x-axis. Let's keep that in mind. So let's say, for example, I gave you just some theta value. So it has, the initial side and the terminal side. And this is some theta value. We don't really care. The reference angle to this angle, to theta, is right here. So this right here is the I can't spell. Reference angle. Because it's formed by the terminal side of theta, that's what this comes from, and the x-axis, which is right here. So this is the reference angle. Now if let's say I drew an angle like this, and I called this theta, then this would be the reference angle. Right here. So let's do a few examples. This is the last thing we're going to learn here. So it says find the measure of the reference angle for each given angle. So I give you, these are just three separate problems. These are three separate problems. What I recommend you do is draw the angle first, and then you should be able to easily see what your reference angle will be. So theta equals 150. Let's just draw a quick sketch. Doesn't need to be perfect. But 150, okay, this is 0, this is 90, this is 180. So 150 is going to land about right here, from your initial side to your terminal side. Okay, so this is 150. So your reference angle is just between the terminal side and the x-axis. So this could be this angle right here. Well, what would that be? That would be 180 minus 150. So in this case, your reference angle is 30 degrees. Let's go ahead and try this one out. 0, 90, 180, 270. Well, actually, sorry, we're going negative. So actually, we should be, sorry about that. Alright, so anyways, it's probably good to look at what you're doing first. Negative 130. Probably put us in here right here, because negative 90 is right here, negative 180 is right here. So we'll say it's about, I don't know, right there. So this is negative 130. So then what's this angle right here? Well, this is negative 130. This is going to have to be 50 degrees. Now, remember what I said is, the definition said it's the positive acute angle. So I don't want you to say negative 50 for the reference angle. This is positive 50 degrees. Let's try 280. In fact, here, let's draw it, but I want you to try it. And this is positive, so we're going this direction. So 280, go ahead and try it out. Remember, draw that angle, but then find the reference angle. Okay, so 280, if you tried it out, it probably landed pretty close to 270. It's positive, so we're going all the way right here. But that's not what we're trying to find. We're trying to find the reference angle, and that's the angle between the terminal side and the x-axis. So that's this angle right here. So if this is 10 degrees, isn't it? Because if this is 280 and this is 270, this is 10. And if one whole quadrant is 90, then this must be 80 degrees. So that's your referencing. Okay. You know, I actually didn't come prepared with a math joke, pun, shout-outs. But hopefully you guys have a great spring break. I know I did. And I'll see you Monday, Tuesday, or whenever.